Okay, let's get started. Please download Laboratory 22 and the population CSV file from Blackboard. Okay, and today we are going to learn some example of probabilities and the hypothesis testing. Okay, please run the first script to identify your host name, username, and current information, and input your name, R number, title, and date. Okay. So first one is an exercise about the histogram figures. In our previous labs, we learned how to draw how to select the bin number and draw histograms, right? But this figure is a little bit different. You see, the width of the bins are not equal, right? So here is the first three, they are all, the width would be 5, 0 to 5, 5 to 10, 10 to 15, but the fourth one would be 15 to 25, so it's 10. And for the last bin, you see the width would be 60, right? So it's a little bit different, but we need to learn how to read the information from these histograms, right? So first question, which bin has more people? 10 to 15 or 15 to 25. So first of all, we need to know the density, definition of density, count divided by total counts, and multiply 1 divided by bin width, right? So that's why here we can compute that density would be the height of the bar, right? And the width would be the width of the bar, and area would be a percentage interest of each bar. So here, this 1% per $1 million, this percent will be the area, the area, not only the height or the width, right? So that's why here we need to do some more calculations. The first one, the bin 15 to 25 has larger area, then we need to use here is 5%, right? No, this is 4%. This one is 4%. 4% and multiply 10 width would be 40%. And then compared with the area of the bin 10 to 15, it's only 5 multiply 5, it's 25%. So the second one, 15 to 25, has more people. Yeah, so it's about this one. And next one, what percent of the incomes are in the 25 and 85 bin? So the last one here, we set the height would be 0.4. I thought it was over volume density. Yeah. Yes, you're correct. Yeah, you're right. Yeah, so the density would be the height, and then if you want to compute the area, then you need to use the density, use the height multiply the bin width. Yeah. Okay. Yeah. Bin density is the height at the bar. Yeah. Thank you. Yeah. And then if you want to compute the people, you need to use the bin width and multiply the height of the bar. The second one here is the width would be 60, right? 85 minus 25, and the height would be 1/5. So here is a 0.2. So it's 25%, 12%, right? And the last one, if you want to draw a single bar over 10 to 25, so how tall it would be, the height would be the density, right? So the first one, you need to calculate how many people are located between 10 to 25. So the area, we need to compute the area. So it means 10 multiply 4 for 15 to 25 is 10 multiply 4, and 10 yeah, the second one would be 10 15, so it is 5 multiply 5, so it's 40 plus 25 is 65, right? The area would be 65, and the bin width would be 25 minus 10 is 15, so the result would be 65 divided by 15, so it's the height would be 4.33. Yeah, so the third one would be 4.33. So it's the answer. Yeah. From this example, we need to know how to read the information from a histogram, right? It's about solution. Okay, so any questions so far? Okay, next one is about the exercise 2. It's about probabilities. So suppose we have 10 marbles, draw 4 at random with replacement. The first one, probability all G's, and second one, probability of no G, and probability of at least one G. So it's a probability, right? So because it is the selection with replacement, so the probability of drawing a G is the same at each time because it is with replacement, right? So suppose we need to compute the first situation of drawing G at the first time. G first time, right? G would be 4 divided by 10, and the second time 4 divided by 10. So they are all the same, right? So that's why here we use the 0.4, multiply 0.4, 0.4, 0.4. Probability of all G's means that you draw a G at each time for the first four times, right? So that's why here the result is 0.025, right? And the next one, no G. No G means you need to select the other 6 marbles, right? So the probability of each time would be 6 divided by 10, so it's 0.6, right? And for each time they are the same. So that's why here is the result would be 0.6 multiply 0.6 into the last one. P no G's, no G. And the last one, probability of at least one G. It means it's a complicated situation, right? It's at least one G. It means you can have a 1G, 2Gs, 3Gs, and 4Gs. So we need to consider the opposite situations. It means no G's, right? So if we can compute the probability of no G, we will know probability of at least one G. We can use a 1 to minus it. Okay. So here, this is the result. At least one G is a 1 minus P no G's. It's 0.87. So it's about the second exercise. So any questions so far? Okay, and if you scroll down to the bottom, then you will see we need to finish the exercise 5 by yourself. I have already given you the answer to the first exercises, but not for the exercise 5, so you need to finish it by yourself. It's related to exercise 2, but only one different. Here it's a random with replacement, but this one is without replacement, okay? So it's different, right? Because if you have drawn 1 G's, then the total number of G's and the marbles has been different. So the probability at each round is different. Okay, for instance here, P all G's. So first time for the first one, the result would be 4 divided by 10, right? And second one would be 3 divided by 9, right? Because there are only 3 G's left and 9 marbles left. Third time for the third one, 2, 8. Last one would be only 1 divided by 7. Result, right? It is the result. It's different because it's without replacement. For second one and the third one, you need to finish it by yourself, right? And for the second one, you see here is P no G. For the first round, no G's. There are 6 no G's and then 10 marbles. Second round, only 5 left and 9, right? And the third round and the last round, you need to finish it by yourself. Okay. and print out. And this one is the same, right? You need to consider the opposite situation. Use 1 to minus the second one. Yeah, so it's about today's exercise. It's related to exercise 2, but not exactly the same, right? Okay, so I need to continue. For the third one, it's really interesting. So so in this exercise, we need to use the population CSV file. This one contains total population of each country in the world over time. Create a data frame and we need to perform the first conduction selection. Use a geo column to select this country. After that, perform another conditional selection, such as the column time should contain the years from 1970 through 2015 and store the data frame. Okay, so it means we need to use double conditional selections. Let's have a look at the population CSV. So you see here, there are only three columns. The first one would be the code for each country. Next one would be the year number, and then the total number, right? And so first of all, we need to use a pandas library, right? It always be the first step. We need to use the pandas library and use pandas.read CSV file, read the CSV function to read this CSV file. And after that, we need to do conditional selections for 2 times, right? So the first time you need to select this country, right? Because actually in the labs of pandas library, we learned how to select some rows. For instance, if you remember, we have a data frame about the fruit and the numbers. We need to select some like minimum number, or which row has the minimum number or has the maximum number. And in this way, we use the country code, right? So that's why here this is the first data frame, right? We call it pop. And the second one we call pop, and it's a connection, right? This is the conditional selection. It means the geo column would be BJD, would be this one, right? So code for a country. And after that, for instance, here I can print out, okay? Print out. So let me show you pop, not that's a tail. Yeah, so let's check the first two. Yeah, so you see here, it's about prediction. Wow, it's 21. Okay, so it's about the last 5 rows of this data frame. So we only select the BJD, means in this one, all the data is from the country BJD, right? And the last one, if you want to know, only for 1970 to 2015, we need to use another conditional selection. And in this selection, we use again, right? Second data frame and select. This one is greater than 1950 and smaller than 2015. And please make sure you use operators. You can use these operators or just use and. Okay. So it's the same. And run again, you see this is the first two, first cell, first, and then you show tail. So because you have done the selection, so if you print out the head, the first 5 rows of the data frame, the first one would be 1970, right? And if you print out the tail, the last one would be 2015, right? So let's check out. Yeah, so you see last 5, so it would be 2011 to 2015. It's correct, right? It's right. It's a right one, right code. Okay, so it's about the third exercise. Okay, so any questions so far? Okay, next one is the last one, the fourth exercise about hypothesis testing. So in this exercise, I will show you how to do the hypothesis testing step by step. The first one here is about the chemical reactor, and the extensive course is a normal distribution, and obtained over 1,000 batches, and is normally distributed by the mean value and standard deviation. So you can construct a normal distribution based on the mean value, standard deviation, and then the batches. Okay, batch numbers. So yeah, so first question, 5 determinations of this A are made. If the mean value of the 5 concentrations is greater than or equal to, this one action is taken. What is the level of significance associated with the test? So the first one, you need to construct this distribution first, right? So we need to import NumPy, pandas, matplotlib, right? Always be the first cell, right? And you can use numpy.normal to create a normal distribution. And the argument would be the mean value, standard deviation, and the batches or the number of the experiments, right? So this one is used to generate a normal distribution, right? And next one is use data to draw up histograms, set X label, Y label, and title. Not necessary, right? But here is histograms. So you see here, normal distribution and the mean value, right? 41.2 and the standard deviation. And next one, we need to do some experiments, right? We need to have 5 determinations. It means we need to randomly select 5 numbers from this distribution. That's why here we need to use NumPy choice again. Yeah, so in one lab, I think maybe lab 17 or 18, we use numpy.random.choice several times, since we need to select one number from 0 to 100. For example, from 0 to 100 for 5 times, 5 numbers, we can use this one, right? And we can also use this one to randomly select 5 numbers from the distribution, normal distribution, right? Here's a random outcomes, random numbers from this distribution, and calculate the mean values of these normal random outcomes, and give you the mean value of these 5 numbers, not the distribution, only 5 random numbers, the mean value of 5 numbers, okay? And after that, run again, let me run again. And run again, so it is only one experiment, so we need to do more simulations. In this example, we do the simulations for 10,000 times and use the outcome. So here, only one result, right? And the outcomes means we want to have 10,000 results. So for loop, NumPy choice, conc 5 a mean value, and append each mean value and outcome NumPy array outcomes. So after you write, it is like 10,000 numbers about the mean value of each experiment, and print out the draw a figure, histograms. And because in the first question, we need to compare it with the 42.3, right? So that's why here we want to have a dot. It's not necessary, right? So if you comment it out, then it is a histograms about your result, experimental result, right? And this one is we want to compare with this one. So it's not necessary because it is x-axis and second one would be y-axis, right? Negative 60 is not important. So perhaps you can set 2000, then check out. So here's a blue dot. The x-axis would be 42.3 and the y would be 2000 or even 3000 or 1000. It doesn't matter, just a dot. We want to compare it with the histograms of your experimental results. Okay, so and Zero is good, but oh, if you said 0, it's hard to determine. So, but here you can see it's the dot, but I think maybe 200 or -1 you can set. That's okay. Not very clear. So 62 is a circle dot. Yeah, so we need to compare it with the 42.3, right? Now you have outcomes, and then you can do the hypothesis testing. So the p-value, you need to set the p-value significance, or the p-value would be, you need to count non-zero outcomes is greater than 42.3, and then divided by repetitions, right? Because here it means you want to have the number of the, how many numbers are greater than or equal to 42.3. Repetitions means the total numbers of the experiments, right? And after that, you can get the p-value, right? It is about how to compute the p-value. It's used to show the level of significance. And the second one, stated null and alternative hypothesis, is the answer. So define the null and alternative hypothesis. Null hypothesis is A is the mean value, right? That's null hypothesis. Alternative hypothesis is A is not 41.2. It's about, because A is generated by this normal distribution. So that's why here we care about the mean value. It's about the solution for the second one. And for the third one, give the statistical inference based on this one. So because we have already computed the p-value from the first question, right? Then the alternative hypothesis must be accepted, because this p-value is it's different, 0.3, because every time, because it's a repetition, right? It's a repetition, so every time you write, the result would be different, 0.26, right? So here is 0.26, but for on your own computer, it would be different, right? But they are all smaller than 1%, so it's highly statistically significant. So we need to accept the alternative hypothesis. It's about the hypothesis testing. How to use, let me repeat the process again. So first of all, you need to generate a normal distribution. For instance, here is conc. And then you can draw a histogram figure to check the distribution of this list. Next one is how to do the experiment. In this example, we need to select the 5 numbers, right? 5 numbers and compute the mean values. And then repetitions for 10,000 times. For this one, 10,000 times, it means we want to simulate it like 10,000 times is pretty large. So we want to show it's convincing, right? And next one, you want to, after that, actually this one is not necessary. We draw this figure to have you clear result, a clear feel about this figure. And the next one, if you have the result, experimental results, you can determine the p-value, right? The p-value here. This is something you want to, it's about the standard value. You want to compare your result with the standard value. And after that, you need to propose a hypothesis and compute with the 5%, 1%, because here is a 1% is a standard. And then you need to determine, accept or reject this hypothesis. No, you don't need to change the number. You don't need to change the number. Only please run all the cells and understand how to set the hypothesis and how to determine to accept or reject the hypothesis. Yeah. Okay, so for exercise 4, any questions? Yes. Just right. Yeah, just right. Don't change anything. Yeah. Okay, so and for the last one is exercise 5. So you need to finish it by yourself. So without a replacement. So please be careful. It's not exactly the same as exercise 2, so please finish it by yourself. And that's all I want to share today. And if you don't have any other questions, please feel free to leave the meeting. Thank you, guys. Have a nice day. And if you have questions, you can stay here. Thank you. Do you I share screen so I take a look? Okay, sure. I will stop recording first. Let me check.